Alright, welcome back. Into this class, we're going to be talking about organic structures. When it comes to organic chemistry, there's a key knowledge that I'm going to expose to you just right now. And if you pay rapt attention to listen to what I'm going to say in a few minutes, it's going to help you when it comes to IUPAC nomenclature of organic compounds as we proceed. So now, let us go to study the structure of carbon. The structure of carbon. You agree with me that carbon is the skeletal element that can be seen in every organic compound in the organic chemistry. So you remember your knowledge of electronic configuration. If you don't know that, I'll teach it in one of my videos, electronic configuration. So using the SPDF addition, where we know that S takes a maximum of 2 electrons, P takes a maximum of 6 electrons, D takes a maximum of 10 electrons, F takes a maximum of 14 electrons, and carbon being an element is number 6, so it's going to be 1s2, 2s2, and 2p 2. Now if we want to represent them by their orbitals, we have the first orbital, then second orbital, then the last orbital, which is the p orbital. You know that it has 3 orbits inside. So now I have first one here, second one, there's nothing here, right? Now this is the ground state of carbon. This is the ground state of carbon. So carbon in its ground state, in its excited state, carbon, the same carbon will have a representation that looks this way. And we'll have there will be excitation here, which will now give us a result like this, 2s1. Now this guy will be elevated to a higher energy level, so we have 2s1, then we now have 2p x y and z. So it's gonna be this, right? Okay, let me do something. Let's click on right, so differentiate it. Okay, so this is the elevated electron in the orbit of carbon. Now remember, from your general chemistry, we know that valency is the combining power of an element. The places where an element is not fully paired, those are the places that another element unpaired electron will come and bond with each other. So that same thing happens when we're dealing with organic compounds. So now in this case, we see that carbon has how many unpaired electrons? 1 unbonded. Electrons are not bonded. 1, 2, 3, 4. So it will mean that for carbon to have a stable structure in the organic compound, for an organic compound to be stable, it means that all the carbon atoms are completely filled up. They are completely filled up. All the carbon atoms are completely filled up. So now let us take a look at something very quickly. So drawing the basic structure of carbon, we have that C for the first member of the alkane family. The first member of the alkane family, which general formula is what? Cn H2n plus 2. We have that C times 1 is what? C. 2 times 1, 2, plus 2, 4. Now we're going to be having CH4, which is methane. So when we draw it, it's going to be giving us what? Something like this. This is how the structure looks like. Okay, so now if we are to draw any other structure, before we go to draw another structure, we need to take note of this. Remember what I just showed us? Carbon had what? 4 valence electrons that can be bonded with. So when you look at this structure, basically it has 4 arms. 1, 2, 3, 4. So it means that for every organic structure that are going to be drawing, it must have what? 4 arms. That is how you confirm if you are correct when you are drawing organic structures. That's how to confirm if you are correct. Alright, let's continue. So let's try the next one. Let's say the second member of the alkene family is what? C2H4. Let us draw the structural formula of C2H4, which is what? Ethane. So let's write C2H. Sorry, it is C2H6. C2H6. Now, as you can see, now let us try for these 2 carbons to know if they both have 4 arms individually. So for here it is 1, 2, 3, 4. For this carbon in particular, it has 4 arms. Now let's come to this carbon. It is what? 1, 2, 3, 4. Now this arm is shared by both of these carbons, but you can see that both carbons individually has 4 arms. This is a basic knowledge that every organic chemistry student should know when dealing with organic structures. Having a basic understanding of this knowledge helps you to successfully draw any organic structure. Now let's try another one. Let us try propane. Propane, which is what? C3H. 3 times 2, 6 plus 2, 8. So we're going to be having C3H, 8. Okay, now let us check if all the carbons have 4 arms. For this carbon, it is what? 1, 2, 3, 4. For this carbon, it is what? 1, 2, 3, 4. For this carbon, it is what? 1, 2, 3, 4. So all carbons in the organic structure must have 4 arms. That is the proof that you are in alignment with what you are doing, that you are correct. If this is not properly taken account of, a lot of people make a lot of mistakes. It is not always obvious when you are dealing with alkanes, but when you start dealing with structures like your alkenes and alkynes, a lot of people have issue drawing correct structures. Now let us go to the next thing we have today. So the next thing we are dealing with is rules for naming organic compound. We have successfully established an agreement about the structure of carbons as it relates to organic compounds. Now we're going to be knowing the rules for naming organic compounds. The first rule is what? You identify, I'm not going to write completely, just pay attention, the longest carbon chain. Identify the longest carbon chain. The longest carbon chain is always known as the parent chain. The parent chain, that is where you build up to name your organic compounds. Now the next thing to do The next, after identifying your longest carbon chain, there is the next thing to do. The next thing is you number them. You number the carbon chain which you have chosen. Number the carbon chain. After numbering the carbon chain from both ends, the next thing to do is you identify if there are substituents. Identify if there are what? Substituents. The substituents will either make it branched. The substituents can be methyl, the methyl groups. Yeah, they can be the methyl groups. Sometimes they can also be substituents can be the alkyl groups. Alkyl substituents, they can also be halogens, etc. Now the next thing is if the substituents, say methyl, appeared in the organic compound more than one time, we use di. If it is 3 times, we use tri. If it is 4 times, we use what? We use tetra. All these things will be clearer when we now start drawing structures. Alright, so the next rule is to assign numbers to our substituents. Obviously, after assigning numbers to our substituents, then the next thing is to name the substituents. Okay, let us quickly go to naming our organic compound. A lot of other special rules is going to apply as we move forward. So we're going to be using different examples. The example is going to be short. In our next video, we'll now start naming organic compound based on the homologous series. Now let us start from the alkane family. So let us draw a structure like this. Pay attention clearly. So in a structure like this, what is the longest carbon chain? For some people, the longest carbon chain is obviously this way, but we don't really know. Let us confirm. So we'll start from here. 1, 2, 3, 4, 5, 6, 7. When you move this way, it's obviously 7, and that means this place is an attachment and this other place is an attachment. You can also move this way. You can also count from here. 1, also count from here. 1, 2, 3, 4, 5, 6, 7. If you count this way, it means that this and this is an attachment, just likewise. So if alright, so now let us go this way. Since we are going this way, let us completely draw our structures. Put hydrogen here, put hydrogen here, put hydrogen here, put hydrogen here. How am I sure what I'm doing? Remember the length of the carbon arms. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 1, 2, 3, 4. We'll come to this guy. 1, 2, 3, 4. So we can just write it as CH3 here, CH3, and here CH3. So what is the name of this compound? The name of this compound is what? We are going to come to that. So let us count the number of carbons. 1, 2, 3, 4, 5, 6, 7, right? So as carbon number 6, because obviously you have to number your carbons, let's say we are counting this way. This is carbon number 6, but for counting this way, this will be carbon number 2. 1 2. If we count this way, here will be carbon number 6. So see 1 2 3 4 5 6. But when we count this way, it's going to be 1 2 3 4 5 6 and 7. So why we'll consider this way is because our substituents, we want it to have the lowest possible number. These substituents, both of them, we want them to have the lowest possible number, right? So let me clean this stuff to make it neater. We want our substituents to have the lowest possible number. So this is, first of all, a 7 carbon chain compound, and for an alkane family, number 7 is what? Hexane. Sorry, hex is 6, is heptane. So now, as carbon number 2, we have methyl twice, so it is 2 2 dimethyl hexane, 2 2 dimethyl hexane. Let us try another. Let's say I want to draw this. Okay, so what's the name of this structure now? First of all, we know what the longest carbon chain. The longest carbon chain can be obviously this 1 2 3. Can obviously, we number our carbons 1 2 3. That means that carbon number 2 is our what? Attachment. When you count from the from your right hand side back, it's going to be what? 1 2 3. If you count from the left carbon forward, it's going to be what? 1 2 3. So you see that the point of the attachment, at the point where the attachment is located, which is this one, it has carbon number 2 on both ends, so we don't need to consider the lowest possible outcome. So this is going to be what? 2 methyl, this carbon number 3, this was propane, 2 methyl propane. That's simple, right? So let us check another example here. Let us see this example. So you have something like this. What is the longest carbon chain in this format? In this case, I'll advise you to pause the video and come back. Alright, let's try it out together. The longest carbon chain. For some people, they will consider this place an attachment, and they will now here CH3, obviously. So we have H. So there should be H here too, right? 1 2 3. There should be H here too, 4. So to some people, here is an attachment. So what I want to call this 1 methyl propane. Is that correct? Obviously, I think it is totally wrong. If you see this kind of structure and straight away think that here is an attachment, you might be making a very big mistake. Here, my dear, is still part of the chain. If you move like this, you see that this is one straight chain. So it's obviously 1, 2, 3, 4. So we're going to call this what? Butane. We're going to call this butane. So for me, I personally think that the first rule, which is knowing the longest carbon chain, is what I consider the golden rule. The golden rule. When you are able to identify your longest carbon chain, you are likely not going to be wrong with naming your structure. When you know how to identify the longest carbon chain and not being impulsive and each time, and also making sure that you adhere to the carbon structure principle, that is making sure that each of the carbons have 4 arms, you cannot be wrong at all. So I don't want this video to be so long, but I just wanted to show us how to use the rules in naming organic compounds. In our subsequent videos, we are going to be naming organic compounds straight without going back to the rules. Let us try a few more rules before we round up for this video. Okay, so let's try this example. See, we have a structure like this, and we have a compound like this. Most at times in organic chemistry, when you see the compound X, it means a halogen. X represents a halogen in organic chemistry. R represents an alkyl group in organic chemistry. So how do we name this kind of structure? How do we name this kind of structure? So by our rules, first of all, we know that our longest carbon chain is 1, 2, 3, 4, 5, 6. So we're doing what? We're dealing with hexane, because this is a single bond organic compound, which is in the alkane family, the 6th member of the alkane family. Now we have substituents. Chlorine is as carbon number what? When we count this way, it's going to be 1, 2, 3. As carbon number 3, there's chlorine. As carbon number 2, there's chlorine. And as carbon number 3, there's chlorine. And as carbon number 2, there's chlorine. So it's going to be what? 2, 3, 4. How many chlorine? 3. So it's going to be trimethyl hexane. 2, 3, 4 trimethyl hexane. Okay, how about try something like this? Something fun. Look at this. We have a scenario where chlorine completely represents all the hydrogens in methane. What can this be called? This is tetrachloromethane. Okay, so these are many more. As we draw more structures in organic chemistry, you are going to see a lot of more rules, how the rules are applied. In our next video, I'm going to be teaching about the IUPAC nomenclature of alkenes in totality, the IUPAC nomenclature of alkenes, every possible problem that is out there that can be solved. Thank you for watching this video. Do well to like, subscribe, share this video to your friends. It's going a long way to help you better your understanding in chemistry. And please don't play with the rules. Remember what I say, the rules are very very necessary when we are dealing with organic compounds. Okay, see you in our next video. Bye.